Oh, okay, here we are looking at the rest of the quiz review. For question 5, we can talk about this both by hand and using your calculator. Which of the following coordinates is not on the graph of the given function? Well, we could just kind of check this out by testing each value. So if this ordered pair -1, 0 is on the graph, what that would mean is if when I evaluate function r at -1, I would get 0. So let's find out if that's true. So let's do the math. Underneath here is like having a parenthesis, so -1 plus 2 is 1. And so I'd have 1 over 1 minus 1. And that, in fact, is 0. So this seems to be on the graph. That works. Okay, they want us to pick the ones that do not work. Okay, I'm going to go underneath. So r at 0 would mean plug in 0 to the function. 0 plus 2 is 2, so I'd have 1/2 minus 1, which would be -1/2. That seems to be correct as well. For this point, I would want to evaluate at 1. So r of 1 is 1 plus 2 on the bottom. 1 plus 2 is 3, which is 1 over 3, which is 1/3. And that is not 2. So this one is not on the graph because it doesn't come up with a true statement. Here I'd have r of -2, so plug in -2, and this just gives me the heebie-jeebies because look at this right here. That's a big problem, right? Because I'd have 1 over 0. That can't be done mathematically, so certainly I am not going to get this point. There's going to be an asymptote for this graph at -2. Now, if I wanted to do this using my calculator, or at least in part, I would look here and first put in my equation, make sure you use parentheses appropriately. I might want to look at my graph just to get an idea of what's going on. But something that I would really make use of is the table set. And if you've not done this before, well, it is your lucky day because this is a cool thing to learn. So we'll come here to table set, and instead of having this on automatic, we're going to have the independent variable be on ask. Okay, and this was in table set, which you find on the same key as window. And then if you do table, which is on the same key as graph, then you have just a blank XY chart. And so this question asked me to find out things about x being -1. It asked me about x being 1. It asked me about x equal to 0. And it asked me about x equal to -2. And then I can compare this table with the points that were given in the problem, and the ones that match are true, and the ones that don't match are false. Okay, so it's kind of a nice way to do the question as well. Okay, question number 6. So this has a lot going on, right? There's just a lot to this question, but the great thing is that all the pieces will fit together. So I look at this question, and one of the first things I notice is that x cannot be 3 in this equation. So I know that I need to have a split in the x direction at 3. And I can see that the +1 would slide the graph up 1. And so instead of having an asymptote on the x-axis, I would have an asymptote at 1. So that's like my scaffolding that the rational function has to fit around. I could now fill out that my domain has to split at 3. And my range has to split at 1. Okay, so for x-intercepts and y-intercepts, this is true for all time, you guys. If I want an x-intercept, I want y to equal 0. And if I want a y-intercept, I want x to equal 0. So to find those points, I can just substitute in. So for example, the y-intercept, if x were 0, I'd have 2 over -3, put in 0, plus 1. So 1 plus -2/3, or -2/3 plus +1, I don't know why I just flipped that, is 1/3. And so that point is round about here. And then if I were solving the other direction, this is when y equals 0. So I'd have 0 equals this equation. I'm going to go up here. So that would be -1 over 1 equals this. I just wrote that as a fraction to help us out. And cross multiply and solve. So then I have the point 1, 0. Okay, so plot that over here. So I like kind of working on the graph and the other stuff at the same time. That's my own take. Okay, the asymptotes we actually already found, so I'm just going to write those down. My horizontal asymptote, my vertical asymptote. And then it mentioned finding any translations. Oops, there's a lot of things on my computer right now. Find any translations or transformations. Okay, so we mentioned that the +1 was sliding up 1. This x minus 3 moves the graph 3 to the right. And then there's a stretch in the vertical direction by 2. Okay, so I'm not going to write all that. That's on my next slide, so I will just show you that. But if I wanted to graph now, finish my picture, I think those 2 points are enough of a hint for me to be able to draw decently well. I think I might want another point over here because I don't really know what's happening there. So maybe put in 4. Anytime you're not comfortable drawing, you can always put in points. And I got 3, so 4, 3 is a point on the graph. Maybe also 5. Let's try that. F of 5 would equal 2 over 2 plus 1, so 2. And that will help me just, at least theoretically help me, if I could draw it all. Draw something that looks lovely like this. Okay, so the part that I said I wasn't writing down is this transformation. We said that out loud. And this is what your picture should look like. It's this part over here. Okay. All right, let's take a look at number 7. So number 7 is written in the strict form of a polynomial over a polynomial. And so to find, I'm going to kind of skip around, but the vertical asymptote, I'm going to think about that bottom being 0 because I don't want that. Don't want that to happen. And I can see that that would happen if x was 2. So I cannot have an x value of 2. So in my domain, I will exclude the 2. There's going to be a split at the 2. And in my picture, that would be reflected with this asymptote. The dominant parts of the top and the bottom, okay, are going to be what determine my asymptote the other direction as well as the range. So if I have a function that is going to act like 6x over 2x as x gets bigger, 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 that's like 3. So I know my horizontal asymptote is at 3, which means my range splits at 3. There's a break in the range instead of being all real numbers. Then, as I mentioned on the last question, if I want a y-intercept, I let x equal 0. If I want an x-intercept, I let y equal 0. So here, if I were to plug in 0, I would get -3 over -4, which is -3/4. And that point is right here. If I have 0 for y, I'd have this. I just made the 0, 0 over 1, so I could think about it like cross multiplying. And so I'd get 6x minus 3 equals 0, or 6x equals 3, or x equals 1/2. So that's my value for right here. So my x-intercept is at 1/2. All those points are kind of close together. All right, and then I could find a few more points to make it easier for me to draw the picture. I could use my table function on my calculator. I could just plug and chug a few points. And I would have this picture. I think that's the end, isn't it? It is. Look at us. Done for the day. Thanks.